Very quick demonstration now of how you would use the Triton Laboratory software to run a experiment on your TTDMA. First thing to do is to click on the icon on the computer. This can be either a desktop, a netbook, or a laptop. It can run on any platform, the software. It can run on XP, Windows 7, Vista. And we combine our software with Microsoft Excel, which is again any of the platforms, the Microsoft platforms that are available can be run. So if I click on the Triton Laboratory icon, that will load the software platform onto the screen, and it'll also initiate the instrument. And we can see that currently we are now connected to the instrument, and we can see that we've got the DMA live, and we've got a temperature reading of about minus 4.5, 1.6, and a frequency of 1, defaulting to 1. To run the instrument and do this very quickly, I'll run through those when the instrument started. You click on File, and you can see that you can choose between New Experiment File or open an existing file. If I go to a New Experiment File, you can see then you've got a choice between DMA and DMA with humidity. The DMA with humidity allows the humidity channel to be inputted into the DMA data. So currently this is actually just a DMA, so we can click on that. It's now going to open up the worksheet. I'll let that open up. This is actually being run on a netbook, which is a very weak PC, so a little slow, but it will show quite clearly that there's no problem running the instrument in this format. If I just bring that up to a full screen, we can see a bit clearer. We can actually populate this. It's free. It's a freehand thing. You can put anything you like in here. We could change this to what the sample is. It's a composite sample. Okay, and we can click Next. And the next thing we have choice of is the various types of experiment. Currently it's single cantilever bending and temperature is registered there. That would have been what was run previously. If you want to, you can change this at this point here through the actual touch screen. You can change the geometry at this point and put in your geometry values. That is what probably most people would do. Or you can do this at the end of setting up the actual software itself. Then you can choose the type of experiment. It's currently a temperature scan, but you can choose between a time scan, an isothermal, a stepped isothermal, or you can customize it with multi-ramps. That accommodates virtually any type of experiment you're likely to do. We're going to stick with a temperature scan for this demo, and we're going to go to 200 degrees, so I'll change that. And we'll change the heating rate for speed, and I'll go to 5 degrees a minute. And we'll click Next. And this brings up now the settings for the DMA. DMA settings. We can choose between multi-frequency or a single frequency. And we currently have 1 Hz and 20 microns. If you click multi-frequency, it will actually allow 2 frequencies, 1 and 10, to be taken, or you can choose individual frequencies by clicking that, or you can choose a log range and put in any number you want in here. Bear in mind that it's not sensible to put in possibly more than about 4 or 5 on a thermal scan at the sensible rates that we normally put in. But if you do step isotherms, then it's quite possible for you to have almost as many as you want. Certainly you can have up to 100 frequencies with no problem at all. If we go to the next stage down here, we can actually see that we've got a dynamic strain control is on. Means that it's actually going to auto control the strain and attempt to achieve 20 microns at all times. This is the default, and we normally don't change that. but you can actually do so if you wish. The broken sample detector is a nice little tool that we've put into the software, which switches off the instrument if the stiffness falls below a minimum level. In this case, with this composite material, we can safely switch that off and not worry about it. Further, for more advanced use, you can go to the advanced force table, and I'll just scroll that down a little so you can see. And that will allow you now to change things like, or add a static force should you wish, on top of the, and this can be positive or negative on the drive, and that obviously can be used for more complex experiments like doing creep and so on. So that will do for the setup in this case, and we can use those conditions, and we can give it a file name, and I'll call that test comp. We can save that. At this point now, we have the choice of crash cooling. If we wish, we can cool the instrument down with the cooling device. There's a separate presentation on that. I suggest you look at see how that is done. And you can go in here and use that. And that will allow you to choose between crash cooling and control cooling as well. You can do this before you actually start the run, if you so wish. Or you can mount the sample now, if you've not done so already. You click that, and this will allow you to actually change the clamping arrangements and input the geometries if you wish. So if at the moment it's single cantilever, if we want to, we can go here and we can choose from any of the other geometries. Very straightforward. We can go to the drop down list and choose any of those, and you can also add a custom geometry with your own geometry constant. So we're going to stick with single cantilever in this case. Okay. Just go to mount the sample. And if you wish, you can change the geometry values. I'll change that to 10, 12, and we can update that. And now it's changed the geometry in that way. This can be done through the touchscreen as well, and again this is probably more normal to do so. And just here you can actually get a description of the geometry constant that's been calculated from that geometry, and an estimated range for the modulus that you can achieve based on the stiffness range of the instrument. In this case it's going from 10 to the 6 to 10 to the 12, which with this composite material should be more than fine. Close that down now. And in fact we're ready to go, so I can press the start button and the experiment will start. What it's doing now is it's going to start opening up Excel spreadsheets, which will be used both for presentation and storing of the raw data. The instrument has been initialized. The Excel sheet has opened up, and it will now start populating those. The first sheet that comes up is actually the experiment template, and you can see that all the information that we've been putting in is now beginning to show. You can see that there's a target temperature of 200 degrees, which is what we put in, the displacement of 20 microns, and if you scroll down you'll see the rest of the settings available. Let that populate the rest of the sheets. It's initiating the various sheets as we go. There's another one just popped up there. In the background the experiment has started, and it will actually start to download data in due course and fill those sheets accordingly. now see that the main presentation sheet has opened up, and in a moment we'll start to see some data being put into that sheet. Go to the Results tab. You can see that the columns show the sort of information that is being downloaded. It also gives you a good indication of the traceability. You see the population of the worksheet is beginning to occur now. These in fact are the raw machine numbers basically coming in. This is the basic signals coming into the software, and you can trace that all the way through the software to the main things that are outputted from the DMA, which are the modulus, the storage modulus, the loss modulus and time delta information. This software does allow you to actually create new sheets, new live worksheets as well, so I'll do that in a moment. What I'll do is now show you that we are actually populating that worksheet. If we want to create another live worksheet, we can do it here. We can create a new worksheet here. I'll give it a quick chart name, and build this with something sensible, of course. It's the x-axis is temperature, and we can actually create a new sheet, and I'll put on this one, which is the ratio of the sample to total stiffness. This is quite a useful thing too. Bring that. And now it's creating yet another worksheet. It's completely up to you what sort of information is presented, and obviously you can create your own columns of data as well if you so wish. This data can be exported and used separately and worked on separately if you so wish, or you can use it, work on it here. Because it's Excel, it has all the functionality of the normal Excel, and it's very easy to paste and overlay worksheets and data. You now see that I've populated this with the ratio of the sample total stiffness at 1 and 10 Hz, and you can see the two traces, and they're live as well. Close that down now. Sorry, cancel that. I need to minimise that. Minimise that. And go back to this main control sheet and just quickly go through these. There's a pretty well standard things that you find in Microsoft products. You can see that they're standard Microsoft configurations. This is quite a useful thing. You've got the instrument controls there. This duplicates to a large extent what is done on the touch screen, and you can change the conditions here if you wish, or you can change them on the touch screen. That's during the run or before the run. You can do it here. The experiment, you can show the status, you can save it, you can save the experiment, and you can rename it. You can stop the experiment, and you can show data in Excel as well if you wish. And you can export the data. It is a point that in fact you can close down the Excel and then open it up again. If I go to the end here, these are fairly standard Microsoft products, but if you go to the end here, one thing that is useful is this thing here. You can go and see, if I go to the Triton Laboratory application, this is a very good help thing. It's an overview, installation of the software, setup and running the instrument, and if you go to the index you can see that you can get some guidance pretty well on running an experiment, setting it up, etc, etc. So there's a built-in mini helpline in there which can help you when you're using the instrument. I'll just quickly go back, and I'll just minimise this, and we'll go back to the Excel sheet. And we can see that this is now generating information, and we could progress that until we've completed the sample. But I think that nicely illustrates the software and how you can quickly get the thing running from a cold start. Thank you very much.